Good evening, everyone. Welcome to the problem solving session of environmental chemistry. This is week 11th. In these sessions, we'll help you solve different assignment problems as well as if there is any doubt, we'll help to the best of our knowledge to solve them. These sessions will help you in solving assignments as well as it will take care of the further examination if you have enrolled for it. So my name is Mansi Tripathi. I am TA for this course. So we'll start with question number 1. So the question number 1 is, in a half reaction involving nitrate and ammonium, if the PE is 8.0 and the pH is 7, okay, the ratio of nitrate to ammonia comes out to be X into 10 raised to power minus 19. So this is the ratio of nitrate versus ammonia. So here we can see nitrate is so much greater than ammonium ion. What is the X? We need to find out the X. So a hint is also given in this question. First of all, work out the balanced half reaction for the given couple and then using the standard equation find out the ratio. So in such questions, it will be better to always write the half reactions first and then we can work out. We know the standard equations and we can easily find out the ratios. So please try to solve this question. And in these questions, options are not given. Okay, so you have to enter the value. These entered value will be in some range. There will be a minimum range to a maximum range. The answer will come in that particular range. So if you are going out of the range, even with the 0.001, it can give you wrong answers. So the range will be mostly you have to put after decimal two significant figures. So go with that, and your answer will fall in range if you have solved correctly. So we'll see the solution now. So first we see that there is the first of all we should write the balanced chemical equation. The half reaction, balanced half reaction. So this is our balanced half reaction. Now we know that Pe is equal to Pe naught minus NH divided by N, pH minus 1 by N log and the ratios. So we have all these values, right? We know the Pe is given as 8. We know the pH is also given at 7. Pe naught, we need to find this out from the textbook. NH, N, everything we know. Now we just have to put this in the equation, and just by solving this simple equation we can very well get this value. So nitrate by ammonia is equal to 5.75 into 10 raised to power 19. So what will be our answer? Our answer will be just x is equal to 5.75. So this is our answer. This is what you have to feed in the given box. Coming to next question, among the following redox couple of common metals, aluminum ion versus solid aluminum. So like this Pe value is given a Pe not value. Such kind of values will be given in the textbooks. So you can take out from that for solving question number 1. Here in this question, these values are given. So in examination, like we see these values in question number 2, in question number 1 also these values will be given. So you don't have to refer to the book. So for the first couple, we have this value. For the second, 5.74, and the for third, that is lead, we have 28.64. Which of the following couple contains the most potent oxidant and which has the most potent reductant? Please let me know the answer of this question. Take some time and solve this question. We'll see the solution now. So the solution is option A, means this has the most potent oxidant, and aluminium, this has the most potent reductant. The higher value of this is Pe naught, it will go up, the more potent the oxidant, and similarly lower value of Pe naught, more potent the reductant. So which has the highest value of Pe naught? 28.64, right? So that is why this has more potent oxidant. And lowest Pe naught here, because the value is minus 28.57. So lowest potent reductant. Coming to the next question, in the module 52, we talk about analogy between pH and PE graph. Okay, this was taught in lecture number 52. Match the following with that. So we have to match the analogy. Okay, so base plus H plus is equal to acid, and oxygen plus electron is equal to reduction. So these are so in these two columns the values are given. This is the column 1 and this is the column 2. So what you need to do is to match the columns. You have to match column 1 to column 2 based on the analogy between pH and PE graphs. So what will be the answer? We'll see the answer now. So answer is option B. A will be matched to option Q, B with option S, C with option P, and D with option R. So so it is just a memory based question. All you need to understand the solution, that P naught corresponds to pKa, A oxidant corresponds to base, and so on. Coming to question number 4, assuming the following reaction occurs. So this is the reaction, this is a half reaction given, and we have to assume that this reaction is occurring. So we need to identify the electron donor and electron acceptor. So what are electron donors and electron acceptor? Electron donors are the compounds which gives out electrons, so they are oxidized. And electron acceptors are the compound which accepts electrons, so they are reduced. So in this system, which of them are denoting the electron, which of them are accepting the electron? So for solving such question, what we need to do is we need to find out the oxidation number. So here Mn2 plus is an oxidation state of 2 plus, and here for oxygen it will be -2. So let us assume X is the oxidation state of MnO2 in this compound. So X minus, how many oxygen atoms are there? 2. X plus, what is the oxidation state of oxygen? It's -2, right? Which is equal to 0. So what is the oxidation state of X? It is, and this is this X, okay? What should oxidation state of X? It's +4, obviously. So here oxidation state of Mn is +4. So Mn is denoting electron, right? So this is being oxidized. So answer will be option C or D. Now let's talk about oxygen. So here oxidation state is 0. Here oxidation state is -2. Right? So we got our answer, right? So Mn2 plus, it's written here also, it's changing from +2 to +4, and oxygen is changing from 0 to -2. Why it has 0 oxidation state? Because in elemental form Any gas will have zero oxidation state. Next question is, using half reaction in standard books, determine PE oxidation and reduction for the following. Oxidation of ammonia to nitrate by the reduction of oxygen to H2. Write the half reaction from the standard books. I'll give you a minute to do that. Then we'll solve this question further. We'll see the solution now. So the answer will be between from 6.5 to 7.5. Let's see how. So these are the half reactions written. Oxygen H plus, it's converted to H2O, and the half reaction for the next process. So this is for reduction, half reaction for reduction, and this is half reaction for oxidation. So just by adding both the things, we can get the solution. So this is our solution. It's coming 7.05, which is falling in between this range. So as I told in question number 1, the answer should fall between the certain range. Then your answer will be correct. Coming to question number 6, water at pH of 7.0 exists in equilibrium with a gas containing 21% oxygen, 0.05% ozone, and this is the equilibrium. Ozone plus 2H plus 2 electron yields to oxygen plus H2, and PE naught value is 35.06. Determine the PE of the above reaction at mentioned concentration. So these are the options given. Try to solve this question so that we can move forward and see how it is solved. We'll see the solution now. So the answer is 26.75. We'll see how it is solved. So just by writing the equation of PE that as we have seen in question number 1, after writing this equation we have all the values and we got our PE values 26.75. The next question is, determine the ratio of total dissolved arsenite to total dissolved arsenate at the pH of 6 and PE of 5. Please try to solve this question. This will also be solved like the previous one. We have all the values, we just have to keep them. We'll see the solution now. Answer is 5.24 into 10 raised to power 16. We'll see now how it is solved. So this is simple half reaction. We know the P E naught value, this from the literature or from the textbook. P is equal to P E naught and keeping all these things. So here we can easily get the solution, which is 5.24 into 10 raised to power 16. The next question is, what is the theoretical oxygen demand of cresol? This is disintegrated or mineralized to CO2 and H2O in milligram O2 per milligram C. Just write the equation of the combustion, then you can get the solution. It's very simple. Write the equation. We'll see the equation in a while. We'll see the solution now. So the solution will lie between 2.02 and 3.02. It's a wide range, and you just have to write the equation and see how it is being solved. So we have to find out milligram oxygen plus milligram carbon. So how much oxygen is there? It's just look at the oxygen. 8.5 is the coefficient. Number of oxygen atoms 2, and mass of oxygen atom is 16. Simple. And per milligram of carbon, number of carbon atom is 7 into 12. Okay. So if we are leaving it till here, that won't that will give us it will depend upon the number of carbon. That can also be a right answer, because the number of carbon is 7 into 12 only, but we have to solve it in terms of cresol. So that's why we will add 8, that is number of hydrogen atom, and 16. I have doubts in this question. When I'll upload the solution, then I'll get it cleared for you. Because they are asking in number of oxygen per milligram of carbon, not per milligram of cresol. So that's why I have doubts if we will take in the denominator number of carbon or just the cresol. So I'll clear this out for you. Next question is connected question 9 and 10. So this will be the last two questions. So please note down all the parameters that are given in this question. A soil sample was analyzed for manganese traces due to recent contamination from nearby factories. The soil solution contains 10 raised to power 5 molar total magnesium and carbon total carbonate. 4 milligrams per liter of total dissolved oxygen. The pH of the soil was 7.5. For the calculation purpose, assume rhodochristosite is possible, solid forming. So this is the rhodochrosite is the possible solid. So based on this, we can solve it further. So please note down all these things so that move to the question. Okay, first of all, we'll figure out this question number 8. So, when we say we need to find out theoretical oxygen demand of cresol, the question should end here. That's it. Okay, this point is unnecessary. This is just creating confusion. So, what is the theoretical oxygen demand? So, total oxygen required divided by total cresol consumed. So, that's all. That will be your solution. So, which is coming as 2.518. So, that will be the correct. No need to consider this further parts. So, I hope you have noted down this question, these given points. Then we can move to question number 9. So, the question number 9 is determine whether the solid rhodochrosite is oversaturated, undersaturated, or saturated. So, the solution is that the rhodochrosite is oversaturated. Visual Mintek will be used to solve such questions. We'll see the solution. So first of all, we'll add the given parameters in Visual Mintek. We are fixing the pH at 7.5. We are putting the concentration unit, oxygen and every other thing we'll add. So this is all the added components. H plus, MnO2, carbonate, oxygen, everything. Then we will give the stoichiometry and mineral components. So rhodochrosite is the possible solid. Okay, so red text is oversaturation and blue text is undersaturation. If we are considering that only rhodochrosite is forming, so rest of the solids will not consider, we'll see only rhodochrosite. And if we are looking at the color is red, and the legend near it is written, it is oversaturated. So our answer was oversaturated. Coming to the next question, the Visual Mintek database includes the reaction shown below for the formation of mineral magnetite. What is the chemical formula for magnetite and oxidation state for Mn in the solid? Mn2 plus 2H2O, magnetite plus 3 plus in electron. So we have seen here, right? Everything, how these are forming. So we need to find out the formula for magnetite and the oxidation state. So the answer is MnO and in bracket OH and the oxidation state is 3 plus, and we'll see how. Limit list of those species that can form based on components that have been defined. So first we were taking everything, now we are just limiting it to magnetite, that we are considering only this is forming. So by putting this, we will get stoichiometry of the solid. Then chemical formula we got to know from here, right? And just by putting the oxidation state, we can get the oxidation state of Mn as 3. So that's all for today. See you next week. Next week will be the last session. So try to prepare all other leftover lectures properly so that we can club everything and understand the problem of the environmental chemistry.